Let's identify the oxidizing agent and reducing agent in this reaction. Let's assign first -1 to fluoride in bromine trifluoride. Multiply that number or oxidation state -1 to the subscript of fluoride, which is 3, that's -3. Bromine here has one atom, meaning it must have an oxidation state of +3. +3 times 1, it's +3. Combining these two numbers, we will get a 0 charge for this compound. For potassium fluoride, -1 for fluoride and +1 for potassium. This compound also has a 0 charge. Our gold here is a free element, meaning it must have a 0 oxidation state, as well as the molecular bromine. Potassium gold 3 fluoride, let's assign -1 to fluoride and +1 for potassium. -1 times 4, that's -4 obviously, and +1 times 1, that's +1. This will leave us +3 for gold, because we know that +3 times 1, of course that's +3, and this compound has a 0 net charge. Now let's identify which of these atoms change their oxidation numbers. It is obvious that gold and molecular bromine here has 0 oxidation states, meaning we can trace from bromine trifluoride if bromine has changed, that's +3 to 0. This means that bromine gained 3 electrons to become 0 charge molecular bromine. So we will write here a mnemonic, GER, GER, G for gain, E for electrons, and R for reduction. From +3 to 0, it means that the number was reduced. Our substance is reduced. This is the oxidizing agent. Bromine here is our oxidizing agent. Now it's clear to us that the other atom or other element must be the reducing agent. And we will prove that one by tracing how the number or the oxidation state was raised from a lower value to a higher value. That is in the case of gold. Gold from 0 to +3. Gold is a metal, and normally metals, they lose electrons. So we can write a mnemonic LEO or LEO. Loss for L, E for electrons, and O means oxidation. Loss of electrons means oxidation. Our substance is the reducing agent. The oxidation state was increased from 0 to +3. So gold here is oxidized. Other species, they actually retained their oxidation states, such as fluoride, -1, all the way from reactants to products, as well as potassium, +1 from reactants to products.